Okay, continuing on in chapter 1, we're going to continue graphing, but we're going to work in two new forms. So our learning objectives for this section are to graph quadratic equations in vertex and intercept form. So here's vertex form is y is equal to a times the quantity x minus h squared plus k. This is vertex form. So important things to notice about vertex form is there's a coefficient, the square of a binomial, right? A polynomial with two terms is called a binomial, and it's squared. And then you have this k that's being added on at the end. Intercept form is y is equal to a times x minus p times x minus q. You'll notice that here you have a coefficient and you have a binomial times another binomial. So when you're looking at comparing and identifying forms, if you're looking for vertex form, you're looking to find a binomial squared. If you're looking at intercept form, you will look at two separate binomials being multiplied together. And the key vocabulary for this section are the two forms, vertex form and intercept form. Again, framing our lesson around some form of regular application. Here we can see that this function y is equal to negative 0.03 times the quantity x minus 14 squared plus 6 will model the jump of a red kangaroo, where x is the horizontal distance in feet. Right? So now we're talking about distance traveled. Right? We'll be talking about height and we'll be talking about distance as we look at this particular model. So x is the horizontal distance in feet and y is the corresponding height. What is the kangaroo's maximum height and how long is the kangaroo's jump? So we're going to look through, we're going to practice a little with intercept and vertex form, and then we will answer this question. So if we take a look at vertex form, the graph of a times the quantity x minus h squared plus k is taking this parabola, the root parabola, y is equal to a times x squared, and moving it. So when you see the word translated, that means a move from one place to another, translated horizontally by h units and vertically by k units. So you'll see that if this is the graph of y is equal to a times x squared, then I move this graph to the right by h and up by k, and I'll actually have the graph of y is equal to a times x minus h plus k. What's important for you to remember is that in all of these forms, we're going to use h and k quite frequently. Horizontally by h and vertically by k. H is always a unit that represents horizontal change, and k is going to represent vertical change as we're working a wide variety of different equations that have h and k in them, but what's consistent between them is that h represents horizontal change and k represents vertical change. Okay, our vertex, the reason this is called vertex form is at hk because I've moved from my root vertex 0, 0 by h horizontally into k, which takes me to this location hk. The axis of symmetry will be at x is equal to h, so a vertical line passing through that point, which would be about here. Right? That would be my axis of symmetry, would pass through there. And the graph opens up if a is greater than 0, down if a is less than 0. So again, if a is positive, the leading coefficient is positive, it opens up. If the leading coefficient is negative, it opens down. So the first thing I want to do is I'm going to want to compare this equation to my form a times the quantity x minus h squared plus k. Now if I want to write it in this form, you'll notice I have to have a minus in my binomial that's being squared, and right now I have a plus. So how can I make that happen? Well, I'm going to have the opposite of x minus negative 3 squared plus 5. So you can see that when I'm looking at h would be here, whatever's being subtracted from x. In this case, -3 is being subtracted from x. And k is this item here at the end. That's 5. Okay, plus k plus 5. So in this case, h is equal to -3 and k is equal to 5. So I know that my vertex is at -3, 5. If I put my vertex in 1, 2, 3, 1, 2, 3, 4, 5, there's my vertex, -3, 5. I know that my parabola is going to open down because my leading coefficient is negative. In this case, it's -1. If you just have a minus sign, that's the same thing as -1. Okay, and what I've got now, I've already got my vertex. If you remember in standard form, the first thing we would do is find the vertex, and here we've already got it. So now I'm going to pick 2 points to the right or 2 points to the left, and I'm going to do an input-output table. Then I'll match with symmetry to the other side. So remember, my axis of symmetry passes vertically through the vertex like that. I'm going to pick 2 points to the right, so -2 and -1. I think those will be the easiest values to pick. What you will find is normally the closer to the axis of symmetry you are, the less extreme the outputs are. So if you remember what the parabola does is it's pretty flat near the vertex, but it gets very close to vertical toward the ends. So if I take -2 and I plug it in up here, I'll have the opposite of -2 plus 3 squared plus 5. Well, -2 plus 3 is 1. 1 squared is 1. The opposite of 1 is -1. Plus 5 is 4. Okay, now we haven't in this course reviewed order of operations, but you'll notice what did I do? I did parentheses first. Then I did exponent. Taking the opposite of something is the same as multiply times -1, so then I multiplied by -1, and then I did the addition. So I'm just very strictly following order of operations. If I plug -1 in, it'll be -1 plus 3 squared plus 5. -1 plus 3 is 2. 2 squared is 4. 4 times -1 is -4, and -4 plus 5 is 1. So these are my 2 points. At -2, I'll be at 1, 2, 3, 4. And at -1, I'll be at 1. Again, I'm going to check distance from the axis of symmetry. This point is 1 to the right. I'll make another point 1 to the left. This point is 2 to the right. I'll make another point 2 to the left. And now I've got enough points to go ahead and graph my parabola. Okay, so vertex form is in many ways the easiest form to graph in because it tells me my vertex. That's the first point I want to find. Then I get 2 points to the right or the left, either one. And I can match then to the other side with symmetry, so I end up with 5 good points to graph my parabola. Okay, a second example. This one's going to open up. I know that h in this case is -1 because this is x minus -1. Right, so you'll notice that h is always sort of the opposite of what you're looking at. This would become 2 times x minus -1, to put it in the correct form, minus 3. So k is this item here, -3. So my vertex will be at -1, 1, 2, 3. That's my vertex at -1, -3. I'm going to pick 2 points to the right or 2 points to the left. I like 0 and 1, so I'm going to pick that. Equally, I could do -2, -3. I get the same results. When I plug 0 in here, I'll have 2 times 0 plus 1 squared minus 3. 0 plus 1 is 1. 1 squared is 1. Times 2 is 2. 2 minus 3 is -1. If I plug 1 in for x, I'll have 2 times 1 plus 1 squared minus 3. 1 plus 1 is 2. 2 squared is 4. 2 times 4 is 8. 8 minus 3 is 5. So here I'm at negative 1, and here I'm at 1, 2, 3, 4, 5. I never put in my axis of symmetry, but I'm going to go ahead and do that now. There it is. This point is 1 to the right of the axis of symmetry, so I'll put 1 in, 1 to the left. This point is 2 to the right, I'll put 1 in, 2 to the left. And then these are the points necessary to do my parabola. Okay, if we look at intercept form, notice it's a little different. Instead of a binomial squared, we have two binomials being multiplied together. What's important here is that the x-intercepts are P and Q. So I'm going to pull P from here and Q from here, and I'll get 2 points that are on the x-axis. That's where x-intercepts are. And I know that the axis of symmetry will be halfway between those points because of symmetry, right? It has these 2 points, which have the same output value, have to be an equal distance from this axis of symmetry. So it's real easy for me to find that point by adding them together and dividing them by 2. So I'm finding the average between the two, the midpoint between these two. And as with all the others, if the leading coefficient is positive, it opens up. If the leading coefficient is negative, it opens down. So in this case, I'll plot my x-intercepts. I'll find the x-coordinate that's halfway between them. That will be the x-coordinate of the vertex. I'll plug it in to get the y-coordinate of the vertex, and then I'll just need one other point on either side. So in this case, I have P is equal to negative 1, and Q is equal to 3. Remember, the form is this: y is equal to A times x minus P times x minus Q. So this is x minus negative 1. That's why P is negative 1. Here's x minus 3. So if I go to negative 1 and 3, 1, 2, 3, those are my two intercepts. I know that the x-coordinate of my vertex will be equal to negative 1 plus 3 divided by 2. That'll give me the place halfway between them. Negative 1 plus 3 is 2. 2 divided by 2 is 1. So my axis of symmetry is going to go right through here where x is equal to 1. To find my y-coordinate, right, I have an x-coordinate, 1. I'm going to plug it in, so I'll have 1 plus 1 times 1 minus 3. 1 plus 1 is 2. 1 minus 3 is negative 2, so here we'll have negative 4. So there's my vertex. It's at 1, 1, 2, 3, 4, negative 4. Now all I need is one more point. I could do the point halfway between these two. In fact, I'm going to pick 0 because I love plugging 0 in. I think it's the easiest thing to do. So I'll have 0 plus 1 times 0 minus 3. 0 plus 1 is 1. 0 minus 3 is negative 3. 1 times negative 3 is negative 3. So here at 0, I'll be here at 1, 2, 3, right there. One unit away from the axis of symmetry to the left. I'll move 1 to the right. There's my other point. And I have enough to graph my parabola. Okay, we'll do one more example like that. This one's going to open down. Remember, this one opened up because my leading coefficient is positive 1. In this case, my leading coefficient is negative 2. I know that P is equal to 3. I know that Q is equal to negative 4. So 1, 2, 3. 1, 2, 3, 4. I want to find the x-coordinate of my vertex. It's going to be 3 plus negative 4 divided by 2. That's going to be negative 1/2. Oh, that'll be fun. So now we get to play with plugging fractions into these types of equations. So I know, though, that my axis of symmetry is going to be here at -1/2, right through there. Okay, if I want to go ahead and find the x-coordinate, we'll get some good fraction practice here. -1/2, and I'm going to plug it in there. So -2 times -1/2. Now, if I'm going to do subtraction or addition with a fraction, I need common denominators. So 3, it's going to be -3, but as halves, that's going to be 6/2. And I'll have -1/2 plus 4, which would be 8/2. Okay, so I went ahead and made common denominators. And out here, my -2 is going to ride along. So -2 times -1/2 minus 6/2, right? So that's -7/2. -1/2 plus 8/2 is 7/2. Okay, so I'll get -49, -2 times -49 over 4. Right? And the -2, right? Negative times a negative, that's going to end up being positive. And the 2 cancels with the 4, and I get 49/2, which is about 25. Wow, that's way down there, right? Way up there. 25. This is only 10, so somewhere way up in that range, my vertex will be at -1/2, 49/2. So it's way, way up there. Okay, I'm going to want to point somewhere in between these two guys. I can pick wherever I want, but again, I really like plugging 0 in. I think it's the easiest thing. So I'm going to pick a point right here, very close. But you know what? Remember, this was way, way up here. This 0 value, it's probably going to be way, way up there too. So I'm going to show you that, but then I'm also going to do another point that I think is going to be a little easier for me to graph. Okay, so it's nice to sort of use these general rules of, oh, I'm picking points that are really close to the axis of symmetry. But sometimes practically in your graphing, you may want to do something else just to make things easier. Okay, so I'm going to go ahead and plug this in. I'll have, right, -2 times 0 minus 3 times 0 plus 4. So it's going to be -2 times -12, so that's going to be 24. So that's way, again, way, way up there. I don't have room on my graph to graph that point. So let's pick another point that's a little closer. 1, 2, let's do 2 and see what happens there. If I plug in 2. I've run out of a little room over here, but I'm going to do it here. -2 times 2 minus 3 times 2 plus 4. So 2 minus 3 is -1. 2 plus 4 is 6. -1 times 6 is -6 times -2, that's 12. So over here at 1, 2, I can get all the way up here at 12. Right? So my graph looks like this. And somewhere up there it's going to happen. It's going to be way up there. You see it's super, super steep. And it opens down. Okay, so there are other things I could have done with my graph, right? I could have gone by 2s, I could have gone by 4s to help bring the size of that graph back on. But this is acceptable. If I label the vertex and I've got a good input-output table and I've got the points, that's sufficient to show me that you knew what you were doing while you were graphing. Okay. So now we're going to take a look at converting from one form to another, which reminds us that when we multiply binomials together, right? So if I take a look at these two forms, right? If we go back to the beginning, if I want to take this form and put it in standard form, I would square the binomial, multiply it times a, and add k, and I'll have standard form. If I want to go to standard form here, I multiply the two binomials together and then multiply the result by a, and that will put it in standard form. So we want to be able to switch from one form to the other when necessary. And so to remind you about multiplying binomials, we normally call this activity FOIL. So the F stands for multiplying the firsts together, and then the outsides is the O, and then the insides is the I, and then multiplying the lasts together is the L. This is really just the distributive property as it applies to multiplying binomials. What's important as we move forward, and you need to be very familiar with this, is right now we're going to be multiplying binomials together. Later when we get into factoring, that's really like unmultiplying binomials, and we normally do that by looking at what could make the firsts and what could make the lasts, and how can I use those factors to combine to make this the correct inside and outside to make this number 11x here. Okay, so we're going to deal with this more in the next sections when we get into the factoring, but I wanted to bring that to your attention now. So if I want to write this in standard form, the first thing I do is I multiply the two binomials together. So I do my first, x times x is x squared. And then I do my outsides, x times negative 6 is negative 6x. And my insides, 1 times x is 1x. And then my lasts, 1 times negative 6 is minus 6. Sorry, when I simplify this together, negative 6x plus 1x is negative 5x. So I have x squared, sorry, not plus, minus 5x minus 6, and I need to multiply that times 4. So h of x, now this is a new thing. What's this h of x thing? What normally goes there would be y. So these are kind of interchangeable. So this would be standard notation. This is function notation. Right? They essentially mean the same thing. What this means is when you plug some value of x in here, into this equation, what do you get? It's the same thing we do when we call it y as an output. So 4 times x squared is 4x squared, 4 times negative 5 is minus 20x, and 4 times negative 6 is minus 24, and now we are in standard form. Okay, so I multiplied the binomials, then I multiplied by the coefficient, and we're done. If I want to do the same thing in vertex form, remember this is going to be negative 1 times, if I'm squaring the binomial, it's just the binomial times itself, and then I can use FOIL. So this would be negative 1 times x squared, x times x is x squared, x times 6 is 6x, 6 times x is also 6x, and 6 times 6 is 36. I want to simplify this. X squared plus 12x plus 36 plus 10. And then I need to multiply this whole trinomial by negative 1. So I'll have negative x squared minus 12x minus 36 plus 10. So I'm going to get g of x. Remember, that's the same basically as saying y, but it's in function notation. Negative x squared minus 12x, and negative 36 plus 10 is minus 26. So if I take this vertex form and I put it into standard form, this is the result. Right, now let's go back and think about what happens with this kangaroo. Right? I know he's jumping from here to there. If I look at this, I go, oh, look at this. This is vertex form, right? I have a binomial squared, and then this extra number. So if you compare that to vertex form, y is equal to a times x minus h squared plus k. So I know that, oh, look at this. H is 14 and k is 6. So that means that the vertex, that would be up here. This is the point where the highest point for my kangaroo's jump. That's the vertex. So that's going to be at 14, 6. That's this point here. Okay, so there's an axis of symmetry that goes through that. Right about there. All right, and what I know is that this point here where the kangaroo starts and this point here where the kangaroo finishes, these both have to be the same distance from the axis of symmetry because they have the same y value. Well, this is 14 units. I know that was how far I moved from 0, 0 to get to my vertex. I moved 14 to the right and I moved up 6. So if that's 14, this is 14, and 14 are 28 feet. That's how far he jumped. So that's the answer to how long is his jump. The y-coordinate, that's this distance here, that's the 6. How high did he jump? He jumped 6 feet high. That was his highest. And how long did he jump? He jumped 28 feet. Okay, so an understanding of what's going on in this problem makes it very easy to figure out what were the values necessary to answer these questions.